Distributed ledger technology, DLT. A computerized system for tracking asset transactions called distributed ledger technology, DLT, allows for the simultaneous recording of transactions and their associated information in numerous locations. Distributed ledgers don't have a central data store or management features, in contrast to conventional databases. A distributed ledger generates a record of every item and establishes a consensus as to its authenticity since each node processes and validates every item. Both static data, like that in a registry, and dynamic data, such that in financial transactions, can be recorded on a distributed ledger. A popular example of a distributed ledger system is blockchain. What is distributed ledger technology? The term distributed ledger technology, DLT, explicitly refers to the technological framework and protocols that permit the concurrent access, verification, and modification of records that define distributed ledgers. It operates through a computer network that spans numerous organizations or places. DLT uses cryptography to encrypt data and to restrict access to only authorized users using cryptographic signatures and keys. Additionally, the technology generates an immutable database, meaning that information that has been stored cannot be removed and that any revisions are preserved permanently for posterity. By shifting record-keeping away from a single, authoritative place and toward a decentralized system where all pertinent entities can read and amend the ledger, this architecture marks a substantial change in how information is received and conveyed. All other entities can therefore see who is accessing and making changes to the ledger. The high level of trust fostered by DLT's openness virtually prevents the possibility of fraudulent activity taking place in the ledger. As a result, DLT eliminates the need for entities using the ledger to rely on an outside, third-party provider to fulfill that duty and serve as a safeguard against manipulation or a trusted central authority to regulate the ledger. In the decade following the 2009 debut of Bitcoin, a cryptocurrency backed by blockchain technology that was the first to show that the technology not only functioned but could scale and remain secure, interest in distributed ledger technology rapidly increased. The greatest development of DLT is its capacity to reduce or eliminate the frequently lengthy and error-prone processes required to reconcile the many contributions to the ledger, guarantee that everyone has access to the most recent version, and assure that its accuracy can be relied upon. Origins of ledgers. Ledgers, which are essentially a record of transactions and related information, have existed in paper form for millennia. They were converted to digital form when computers first became widely used in the late 20th century, even though digital ledgers typically duplicated their paper counterparts. In the past, ledgers needed a centralized authority to verify the validity of the transactions recorded in them. Banks, for instance, were required to confirm the financial transactions they handle. With cryptography, sophisticated algorithms, and stronger, nearly universal processing capacity, 21st century technology has now made it possible for the next step in record-keeping, making the distributed ledger an increasingly viable method of record-keeping. Examples of distributed ledger technology. There are several forms of distributed ledger technology in use today. The most well-known kind of DLT is blockchain, which groups transactions into blocks that are chained together and then broadcasts them to the network's nodes. Bitcoin and other cryptocurrencies are run by it. A different DLT called Tangle is targeted at IoT environments. The Tangle EE Working Group was established by the Eclipse Foundation and the IOTA Foundation and defines Tangle as a permissionless, feeless, scalable distributed ledger, designed to support trustworthy data and value transfer between humans and machines. The distributed ledger technologies Corda, Ethereum, and Hyperledger Fabric are also well known. Why DLT is important? By altering some of the principles of how businesses gather and share the data that goes into their ledgers, distributed ledger technology can significantly improve record-keeping. Consider paper-based or traditional electronic ledgers that need all additions and modifications to pass via a single point of control in order to grasp this. To maintain centralized control in such a system, firms must invest a lot of labor and processing power. Furthermore, due to centralized control, ledgers aren't always accurate or current. Every place that provides data to the ledger has the potential to be a source of fraud or inaccuracies, making the process vulnerable to errors and manipulation. The accuracy of the data arriving from the other contributors cannot be effectively verified by any of the other participants who are providing data to the central ledger. However, real-time data sharing is made possible by distributed ledger technology, ensuring that the ledger is constantly up to date. Due to the fact that each participating node can see these changes, it also promotes transparency. It is inherently more secure since it does away with centralized ledger's single point of failure and single target for hackers and manipulation. Because there is no longer a need to go via a central authority or middleman, distributed ledger technology offers the potential to speed up transactions.